This is Learning Assessment Problem E22. The problem-solving strategy to be applied here is that of Ohm's law and the various power relationships for a resistor. In the figure A circuit, we have a current source connected to a resistor. We're given information about the strength of the current source, 0.4 milliamp, and the power being absorbed by that resistor, 1.6 milliwatts. And we are to determine the voltage across the source, V sub S, and the resistor value. So we can apply the power relationship for a resistor. P sub R is equal to I sub R squared times R, and solve that for the resistor value. R is equal to P sub R divided by I sub R squared. In our case, this is equal to 1.6 milliwatts divided by 0.4 milliamps squared, or R is equal to 10K. Next, we'll solve for the voltage V sub S. We'll say that V sub S is the same as the voltage across the resistor, V sub R, and by Ohm's law, that would be I sub R times R, which is 0.4 milliamps times 10K, and that is equal to 4.0 volts. In the figure B circuit, we are asked to find a current I in this loop and the value of the resistance. This time we have a voltage source of 12 volts connected across the resistor, and we are told that that resistor is absorbing 1/4 watt. In this instance, we'll use the power relationship for a resistor, which is power is V sub R times I sub R. In this case, the resistor current is the current I which we are seeking, and we have that I sub R equals I equals P sub R divided by V sub R, which is 0.25 watts divided by the 12 volt source, or I is equal to 20.8 milliamps. And then we are asked to solve for the resistor value. We can say that R is equal to V sub R divided by I sub R. V sub R is the same as the source voltage of 12 volts divided by the 20.8 milliamps we just calculated, or R is equal to 576 ohms.